Hi everyone, today we will discuss problems based on Newton's laws of motion. So let us start with some examples. Here if you see the first example, say a car of mass 1200 kg is brought to rest. So mass of the car is 1200 kg. Brought to rest from a speed of 72 km per hour. So it is moving with the velocity 72 km per hour. Okay. By a constant force of 300 Newton. It means a force 3000 Newton. 3000 Newton is applied on a car of mass 1200 kg which is already moving with the velocity 72 km per hour. Find how long the car takes to come to rest and the distance the car travels during this time. It means in what time it will come to rest and how far it travels before it comes to rest. So these things we have to calculate. So first this is the velocity of the car with which it is moving, and this is the force applied to bring it to rest. It means we have to calculate the retardation first. So here force is 3000 Newton. So just using, because there are no other forces acting on the car, so we simply have the equation F it is equal to mass into acceleration. Mass of the car it is given, force applied it is also given, and that is retarding in nature. So and here this is 1200 kg that you can see. So just using this simple equation we can calculate the value of this A, that is retardation. So F is equal to ma, so acceleration A, or here it is retardation A, it will be equal to F by m. So we can substitute the value of F, that is 3000, m 1200. This minus sign only signifies that it is a case of retardation, not the acceleration. So just simplifying, we are getting 2.5 meter per second square, and that is retardation. Velocity of the car is given as 72 km per hour. So if you convert it to meter per second, so we will have 7200 divided by 3600, and that gives you 22 meter per second. So this is the velocity of the car. Retardation it is 2.5 meter per second square. Using simple kinematic equations we can calculate the time taken by the car to come to rest as well as the distance covered during that period. So here you can see the final velocity of the car will be what, 0, because finally we have to bring it to rest. Initial velocity is already given, that is 20 meter per second. So we can use this relation just to calculate this time t. V is equal to u plus at. Here it will be v is equal to u minus at. So u initial it is 20 meter per second minus 2.5 into t, so that gives us 8 seconds. So it means the car will come to rest in 8 seconds. Now to calculate the distance covered, we will use this equation as far as the simple kinematics is concerned. V square plus u square is equal to 2as. Using this relation you can consider here A it is again retardation, and we are just interested in the magnitude part of that because finally we are taking V as 0. So 0 u square minus of 2 into 2.5 into s, simplifying you will get 80 meter. So it means after covering a distance of 80 meter the car comes to rest, and it comes to rest in how much? 8 seconds. So let us see the next question. Here in this question if you see, again a body of mass 2.5 kg moves vertically downwards. So a mass 2.5 kg is moving downwards. So once there is an object, so obviously the weight of the object always acts in the downward direction. It is supposed to be located at its center of mass. It is concentrated to be at the center of mass, but it has the tendency to move in the downward direction just because of acceleration due to gravity. But see, it is moving down with A is equal to 19.6 meter per second square. What does this imply? If it is a case of free fall, then it will move only with the acceleration 9.8 meter per second square. If it is simply moving down, if it is just free fall, then acceleration has to be only 9.8 meter per second square, that is equal to g. But here the acceleration is 19.6 meter per second square. This is possible only when some external force apart from acceleration due to gravity, that g, apart from that some external force is also acting on the object, then only its acceleration will be more than the free fall acceleration, which is equal to this g. It means there is a force, let us say this F, which is acting in the downward direction, then only we can expect any acceleration greater than that g. So if you consider this, so we have to find the force which acts on the body. It means we have to find this force F along with the force of gravity during the fall. We have to neglect the air resistance. We don't have to consider any bind force because of the air resistance and all that. So if you consider this force F here, so can we write this simple equation, F plus mg, it is equal to ma. Now acceleration A, it is given, and that is how much, 19.6 meter per second square, and mass of the object, it is also given, that is 2.5 kg. Just substitute in this equation, you will get the value of that F. So that's what we have done here. Mg plus F is equal to ma, such that F is equal to m a minus g. A, it is given as 19.6, g is 9.8. Simplifying, the force applied, it is 24.5 Newton. So this is the force which is applied on the block, so that it is moving with the acceleration 19.6 meter per second square. Now let us see this question. Here in this question, two bodies of masses m1 and m2, this m1 as well as m2 are connected by a thread, and these are connected by thread, string, and lie on a smooth horizontal surface. So this surface is smooth, there is no friction or any other forces acting here as far as the surface is concerned. With what acceleration will the bodies move if a force F is equal to 10 to the power 5 times parallel to the surface, it is parallel to the surface of the table, is applied to the mass m2. What is the tension in this string, that is connecting string, and the masses m1 and m2 are also given, that is 200 gram as well as 300 gram. So just to simplify, let us consider the free body diagram, and if you consider the free body diagram of this m2, so can you say on this block m2 we have this applied external force F. Tension in this string, let us say it is T. Tension in this string, if we consider T, so this T will act what? Act opposite to the applied external force. So we can consider this tension T, and this is your mass m2. So for this block, you will get the equation F minus T is equal to m2a. Because these two blocks are connected together, so because of the application of this applied external force F, it will start moving together with the common acceleration, suppose a. So this a, it will be same for m2 as well as for this m1. So you have F minus T is equal to m2a, and here if you consider this m1, on this m1 you have this tension T only, because there are no other external force. I am talking only of the horizontal forces. So tension is the only horizontal force acting on this m1. So you can write this T, it is equal to m1a. Now simplifying these, there are two unknowns, tension T as well as acceleration a. Simplifying these two equations, you can calculate all the unknown quantities. Masses are also given. Once you finally get the expression for your unknown quantity, you can substitute the value of masses m1 200 gram, m2 300 gram. Just all these are given in CGS units, so you have to take care before you substitute these values. This is clear. So if you are using CGS, so each and every parameter it should be in CGS. If you are using SI, then each and every parameter it should be in MKS or SI system. So just simplifying these two, you can consider. Now here I have considered only the horizontal forces as far as the free body diagram of m1 and m2 are concerned. Just for understanding, if you consider the vertical forces, then the weight of the block is m2g, here it is acting down, and the normal reaction here you can say n2. Similarly here you can say it is m1g as well as the normal reaction this n1. this N1, M1G, N2 or M2G, they are not participating as far as the movement of the blocks are concerned. So you can consider these forces when you draw the free body diagram, or you can ignore it, because we are interested in its horizontal motion, and we are aware that horizontal motion is only possible due to the horizontal forces. Vertical motion is possible only because of the vertical force. Vertical force can't create horizontal motion, and the horizontal force can't create the vertical motion. So taking care of all these concepts, we can either ignore the vertical forces, or if you want to show, you can show it. So here you can see this. So here you can see this diagram. Here it is. Here it is beautifully drawn in this. So you have this force as far as M2 is concerned. F is applied on M2. You have this tension T acting here. Similarly, the same tension T here, it is acting on M1. You can see this clarity of the diagram. Summation of tension for the entire string is what? 0. If you consider the thread as or string as massless, just for it is a hypothetical assumption, but if you assume this, then at every point the tension, magnitude of the tension throughout the string, it is same, and at every point, and every adjacent point, the tension acts opposite to each other, so that the summation of tension for the entire string as a whole or part of the string, it should be 0. So here if you consider this, so this side it is acting rightward, this side it is acting in the leftward. If you consider this part of the string, then this tension and this tension, they will cancel each other, so that the sum of tension becomes 0. Because for the entire string as a whole, you just see the statement that I am making. For the entire string as a whole, the tension, it is what? It is an internal force. So summation of tension for the entire string as a whole or part of the string, it should be 0, because summation of all internal forces, it is always 0. Tension for the string itself, it is an internal force. So sum of tension for the entire string as a whole or part of the string, it has to be 0. But when you consider this string, for this mass M2, the same tension T acts on this M2 or same tension T acts on M1, because for M1 or M2, the same string, it starts behaving as an external object, and when it starts behaving as an external object, it means it starts behaving as an external force. So for M2, T is external, for M1 also T is external, but for the entire string as a whole, T is an internal force, and sum of internal force, it is always 0. So for the string, if you analyze, then summation of tension for every part of the string, you consider this part, you consider this part, you consider this part, it has to be 0, either for the part of the string or for the entire string as a whole, provided mass of the string is assumed to be negligible. If you take the mass of the string, then the concept will change. In that case, lots of other concepts get involved. Moment of inertia will get involved, angular momentum will get involved, angular velocity, angular accelerations will get involved in those things. So those things we will consider in the coming topics, and that will be a case of rigid body motion, or you can say the rotational motion in general. So right now we are assuming mass of the string negligible, so we need not worry about all those things, and we are not involving all those concepts here. So this is the discussion that we have already done. Now see this question here. In the previous question there were 2 blocks, here there are 3 blocks. This is the basic difference, otherwise conceptually these are similar problems. Here you can again see 3 identical blocks, each of mass 0.6 kg, are connected by a light string as shown in this diagram. Assume that they lie on a smooth horizontal surface. Again we are neglecting friction. We are taking this smooth horizontal surface and are observed to have an acceleration of 4 meter per second square under the action of the force F. Yani this force F is applied. Calculate F and the 2 tensions. So acceleration of motion of all these blocks it is given. We have to calculate this applied external force F as well as the tension in this block and tension in this string as well as tension in this string. So let us say tension in this string, it is TAB and here it is TBC. Why this nomenclature TAB? Because this is the block A and this is block B. So this tension is between A and B, so we have this TAB. This is between B and C, so it is TBC. So if you consider again the free body diagram of this A, if you consider, so this F this side, this tension TAB on this in this direction. Again if you consider the masses, so let us say M1G this side and the normal reaction this side. Again for this if you consider this M2G considering its mass as M2 and this is suppose M1. Normal reaction again this N2. This tension TAB which is acting here in the leftward direction because this force has to act opposite to this applied external force. The same tension here it will act in this direction. Here again TBC it will act opposite to this because this force here it is an internal force for the string, but the same force this TAB it is behaving as an external force for this block B. So external force on B here it is acting rightward. So this tension T on B it will be acting in the leftward direction. So TBC in the leftward direction. Here again the same force it will be acting in the rightward direction, such that sum of these two forces it is 0, sum of these two forces 0. Why sum of these two has to be 0 at every point of time? Just because tension is behaving as an internal force for this string, similarly for this string. So this is the free body diagram. So here you have M3G, here you have this normal reaction. Okay, so these are the vertical forces. Again you can see we are again interested only in the horizontal motion. Here this applied force F it is in the horizontal direction, so the movement will be in the horizontal direction. So we can represent all these forces here or we can ignore it because it has nothing to do as far as the horizontal motion is concerned. So now you can write the equation. So for this mass M1 you can write the equation F minus TAB it is equal to M1A. Similarly for this you can write, for this block you can write, because these are the two tensions only, there is no other external force acting here. So for this mass you can write TAB minus TBC it is equal to M2A, because we are considering the mass in consideration is M2, so it is M2A. And similarly for this block C you can write TBC it is equal to M3A. So these are the three equations. Again you simplify these three equations and you will get all your unknown quantity. Here acceleration A it is already given. So A is not unknown. Here unknowns are tension TAB and TBC, two unknowns, as well as this F. So there are three unknowns. Three equations, you have three unknowns and you have three equations. Simplify them and you will be able to get all the required quantities. So here we require this force F as well as the tension. So simplify, you will get this tension as well as this force F. I hope this is clear. So you can again see here these diagrams that we have already discussed. Here you have this tension this side that we have already discussed. Here this side, again this side. We have drawn the free body diagram, simplified, and you will get all your required quantities. You can see these equations here that we have already discussed. So simplifying, we are getting TAB is equal to 4.8 Newton and TBC you are getting 2.4 Newton and the applied force F we are getting 7.2 Newton. So let us discuss the next question. Now here you can see this statement. Suppose that blocks A and B have masses 2 kg and 6 kg respectively. There are two masses A and B and their masses are given 2 kg and 6 kg and are in contact on a smooth horizontal surface. If a horizontal force of 6 Newton pushes them, calculate the acceleration of the system and the force that the 2 kg block exert on the other block. So if you see the diagram here. So here you can see there are two blocks A and B and 6 Newton is applied on A. Okay, it is not given here in this question the 6 Newton is applied on this block or it is applied on this block. So we can consider both the cases. So let us say this 6 Newton is applied on block A. Let us say first we consider this. We can also consider what happens if this 6 Newton is applied on this block B. So we can make two cases out of this. First case, when 6 Newton is applied on block A and 6 Newton when it is applied on block B. So whatever it is, whether it is applied on A and applied on B, the concept will remain same, only slightly there will be change in some value, so that we will see. So if we consider the first case, let us say case A, then again when this 6 Newton is applied on this block A, so this external force is acting on A. This external force 6 Newton has nothing to do with this block B. 6 Newton is not in contact with this B. So 6 Newton is not acting on block B. Let it be very clear. 6 Newton is in touch with block A. It is not in touch with block B. So 6 Newton is not acting on B. Okay. 6 Newton is in touch with A. So 6 Newton is directly applied on this block A. Now, if 6 Newton is not acting on block B, then why should B move? B will move because of some other forces, and that other force is nothing but the force of interaction. As soon as the 6 Newton is applied on this block A will exert some force on this block B. And at the same time, from Newton's third law, B will also exert some force on this block A. So there will be a force of interaction between the surfaces, between these two surfaces, the right contact of A with the left contact of B. If you consider this block A here and block B here. Okay, so this is suppose the right side and this of A, and this is suppose the left side of this. This surface and this surface is in contact. This is a common surface. I have drawn this common surface here. Okay, let us cut the diagram so that you have this surface of A and this surface on B. Now as soon as this force F is applied on this A will apply a force on B. At the same time B will also apply force on A. So that force is common force for the common surface of A and B. That force is termed as force of interaction because that is common for A as well as common for B. A is applying force on B and B is applying force on A. Then sum of these two forces should be what? 0, because again force of interaction, as we say, tension in the string, it is an internal force for the string as a whole. Similarly, the force of its interaction for the common surface, again it is an internal force. So sum of that internal force, it has to be 0. That's why if this force here by A on B it is acting in the rightward, then by B on A it should act in the leftward direction. They will act along the same line. So don't get confused that I have drawn this line here and this line here. That is just for your understanding and clarity of the diagram. But these two forces are acting along the same line, this side as well as this side. This is the force applied by A on B and this is the force applied by B on A. Sum of these two forces for the common surface of A and B, it becomes 0. That's why they are opposite to each other and they will be having the same magnitude. Now, as soon as this F starts acting on this A will apply a force on B, at the same time B will apply a force on A. That force applied by A on B, that force is responsible for movement of B. This 6 Newton is not responsible for movement of B. 6 Newton is responsible for A because 6 Newton is directly acting on this block A. So we will say that A will be moving because of 6 Newton. B will not move because of 6 Newton. But B will also move, and B will move because of this force of interaction. That is the force applied by A on B. So you have to be clear as far as these concepts are clear. So here, So now if you draw the free body diagram of this A, so here on A, you have the 6 Newton from this side, and suppose that force of interaction is, let us say, F dash. Okay. So this F dash here. So on A you have 6 Newton, or F from this side, F dash from this side. So you will get F minus F dash. It is equal to mass of this block A into its acceleration. And for B, if you consider the free body diagram for this B, this F dash on A it is acting leftward. So same F dash on B it will be acting rightward. So this is your F dash. This is the only force. This F is not acting on block B. This is the only force which is acting on this block B. So we will consider F dash, it is equal to mass of block B into its acceleration. Now acceleration of both the blocks, it will be same because both of them will move together. If they don't move together, then there will be separation, and as soon as there will be separation, it means these two blocks will behave as two different identities. So there is no question of all these concepts to be involved in this. So again we will have a different concept for that. So F dash, it is equal to mass of that block B into its acceleration. Simplifying this, we will get the acceleration as well, we will get the force of interaction between these two masses, which we have assumed as F dash here. Same 6 Newton force, if it is applied on block B, what will happen? Every concept will remain same. Only thing is this F dash here, which is acting on this A in this, now it will act on B. So you will write the equation as F minus F dash is equal to mass of the block B into acceleration A. Mass of the block B into acceleration A, and for this only that F dash will remain. So we will write F dash equal to mass of the block A into its acceleration. Simplifying, again you will be able to get all the required or desired quantity. So this way you can simplify it. So if you see the diagrams here, so we have considered both the cases, first for the block A and similarly for the block B, and you can simplify and you will get all required quantities for the block A as well as for the block B. I hope this is clear. So we will continue more and more problems in the next lecture. Thank you.